Hi, in this lecture we are going to be looking at some examples for the pandas series and data frame. To begin with, we are going to be using the Spyder IDE that comes with Anaconda, and here you see on the left side, here is my examples file, and I'm going to be running the codes from the example files, and the output is going to show up in the console. The example file is available as a part of the resource bundle, so you should be able to take it and run it yourself. So let us start off with pandas here. So first thing I'm going to be doing is I'm going to be importing pandas. I'm going to be importing the series and data frame from pandas, the two objects, series object types, series and data frames from pandas. And then I'm going to be importing pandas as PD and NumPy as NP, so that I have some short form aliases that can be used to access any other functionality. And I believe, given your Python background, you should be familiar with these statements, the pandas import as well as the importing as an alias. So let us start off with what a series is. A series is, as we know, a one-dimensional array. So how do I create a series? Is I can create a series from a list like this. So when I say series of and I pass a list to this one, I get a series output. So now the series, as you see, is executed, and you can look at the series like just running the name of the series, and you see the series now shows the various values that you put in the 4, 5, 2, 1. But what you also see is an index on the leftmost side. So an index is also kind of created with IDs from 0, 1, 2, 3. So this index gives you very fast access to the members of the series. So that is one of the advantages of using pandas. Now we have created a series without a named index, but you can also give an index name to what you want to create. So rather than having 0, 1, 2, 3, I can have an associative array or an index that is logical or labels. So I can give labels like this and also create a series. So I say series of 4, 5, 2, and then I'm saying index equal to this logical name, and let's see how this one works. So you run this one, and now you look at the series. You see that the index on the left side is actually showing you apples, oranges, and grapes instead of 0, 1, 2. So this is an easy way for you to access members of a list without having to remember the index value of a specific member. How can you filter data or access data in a series? Is you can just say my series of oranges. So that will only give you the orange member of the series. So you see that my series of oranges just gives you 5. Or you can also access as like this, apples in my series. So apples is the associative array index in my series. Now that you can also access apples to this. Now this apples in my series is a Boolean condition. So this is like I can check whether apple exists in my series or not, and you see that the return value comes out as true. So that's another way you can filter. You can filter by using the label, and then you can also use it more like a condition. How do I add members, additional members? Once I create a series, I can always add additional members like this. I can just give whatever is the new index values, my series of peers equal to 6, and now you see peers is added in there. Now you see my series and it has peers also. So the new member gets added at the end of the series. I can also drop a member of a series by just saying, using the command drop, my series.drop, and I can actually use this command to drop multiple members. I can say my series.drop now, and that would drop oranges. And what it is now doing is it is not doing it in place, rather it is returning you a new series with orange dropped in there. So the original series is not being modified by this drop command. So if you want to modify the original one, then you can assign this to the same value once again, and that should give you the new series without the oranges member. You can also create a series from a dictionary. First I'm creating a dictionary like this. You see my series, my dict is equal to USA, 75, Canada, and 20. And when I convert a dictionary to a series, what happens is that the dictionary labels that I used automatically becomes the series labels. So you now see that the dictionary labels USA and Canada has become the series labels, and then you see the values 75 and 20 have become the corresponding values in that. So that is how you can convert a dictionary into a series. So these are easy to use commands that you can quickly create a series out of. Moving on to data frames. So data frames we talked about as a two-dimensional array or a table kind of representation. So you can create a data frame from a dictionary. So first I'm creating a dictionary with these labels IDs, name and isManager, each one of them containing a list of values. And what you see now is when you go and execute this command and you create a dictionary, first you create an employee dictionary with ID, name and isManager, and you just cast it, or you just say data frame of the dictionary, and that becomes a data frame. So you can choose empdf equal to data frame of empdict, and that converts the dictionary to a data frame. Now let us look at how the data frame looks like. So you see that it shows up as a table representation. So every column, there are 3 columns, ID, isManager, name. Every column has a label, and every row has a row ID. 0, 1, 2, 3 are the row IDs, and every column also has a label, and this becomes a table. So this is your data frame for you. And data frame, each series can be of a different data type. So the first one you see is integers, the second column is Boolean, and the third column is text. You can access members of the data frame in many ways. You can access an individual column like MDF of name, that will give you the entire column name. So you see MDF of name, and that gives you all the rows in that specific column. It also gives you the row IDs and the values. You can also access the same thing by just saying dot name. So almost like you are accessing an attribute of this specific object. You can also access it like that. You can both access it like inside the quotes within the square brackets, or just dot name. You can access a specific row and a specific column by this command, which is mdf.name, which is the name column, and in bracket 2, so that is going to be the third row. So the indexes, the row indexes for a data frame starts from 0 onwards. So it is 0 to n-1. So when I say mdf of name of 2, 2 is actually representing the third row in that specific column. So this third row is the SAM. You can use conditions to kind of filter a data frame. So you say mdf of isManager equal to false. So the isManager equal to false is a condition that's applied on this data frame, and you will only see a subset of the data frame returned where this condition is true. So when you say mdf isManager equal to false, on this mdf data frame, only those records that is matching the condition are returned. It is very similar to in an SQL when you say where something equal to something. A nice way to take a peek at a data frame is this head command. A head command returns the first 5 rows in a data frame only. So if the data frame is huge, 100,000 rows, you can do a head to kind of take a sneak peek at the first 5 records of the data frame. You can also take a peek at the last 5 records of the data frame using the tail command, which gives you the last 5 records. In this case, this data frame only has 4 records, so you're just saying the same data being repeated again. But head and tail, you can also say how many records actually you want to look at, not just 5. You can look at the first 10 or the last 10 as you want it to be. You can also use the index access specific row, which is mdf of iLook of 2, so this is like looking up a specific row. So this looks up a specific row number 2 and returns you this row. This is the row that returns when I say mdf of iLook. iLook is basically use the index to come up with this row, and you see that it is coming up with the values in that particular row. Of course, the values are transposed, so the column names are coming up here on the left side, and the values of these columns coming up on the second column. Now you can add a new column to a data frame by just saying mdf of department ID equal to series. You just pass a new series, and then the only thing you have to make sure is the series has the same number of values or same number of members as the number of rows in the particular data frame, and then you can create a new column just like that. So this gives you a new column called department ID. And now you look at MDF, you have a new column called department ID added in there. So this is pretty quick to add a new column if you want to. Now how do I create a new row? I can create a new row with using this command, which is there is an append command that I use to create a new row. First I create a series, and this is the command that you will use. I create first a series in which the first member is the values that you want to pass. Then there is the index where you give basically the column names that corresponding to these values, and ignore indexes, basically you just go add it to the end. So this is a pretty straightforward way of adding a new column. And once you add a new column, you see the output showing up here, which is it is not going and appending it in place, rather it is returning you a new data frame. So you have to use you have to say MDF equal to MDF.append to actually modify the original data frame. So in this case, the new data frame is returned with the new value added in when you do this command MDF.append. But pretty simple and straightforward. You can create new columns, you can create new rows. Pretty easy to do these things. Pretty easy to do these things in a data frame. Moving on, how do you delete a column? So for doing that, I'm just going to add a new column called dummy equal to 1. When I say equal to, when I just give one value only, when I create a new column, that value is provided to all the rows in the data frame. You can also create like this. So you say MDF dummy equal to 1. Now what happens in the MDF? Let's see. There is a new column called dummy with the same value put in for all the rows in there. I can delete a column by saying del MDF of dummy. So that's how you can do del. There's a del command MDF of dummy which will delete the entire column dummy. And now you look at the same data frame, you see that particular MDF is deleted. How do I delete a row? I can delete a row by saying MDF.drop. So drop will drop a row, and here you're giving the row ID, which is 1. So the row ID 1 is nothing but the second row. So MDF.drop is equal to drop a given row. When you do this delete the column or delete row, it is returning back a new data frame. Again, as I said, if you want to change the original data frame, you have to assign the result of this operation to the original data frame, and that should be a pretty straightforward operation. How do I sort a data frame? I can say MDF.sort index. So sort on the index, I'm saying axis equal to 1. So axis equal to 1 is going to sort this data frame based on the second column. So second column, as you see, it is sorted in. It is going to first sort it by the column name. So when you sorted, the column that is going to come up here is the department ID column, and that's going to be sorted on that particular axis 1, 1, 2, 2. You can also sort it by multiple columns. So in this case, MDF.sort is manager and name, which means it is going to sort by first the is manager flag and then the name flag. So when you say MDF.sort, you can immediately see that it is sorting first by the is manager and then within is manager by the name. So you have multiple sort options here. You can either sort it by the column ID or using the column label, and you can sort it using multiple columns too. And this is very similar to in an SQL how you would do order by column 1 comma column 2. You can take a look at the distribution of various values within a data frame by saying MDF.describe. When you do MDF.describe, what it is going to do is it is going to look at all the number values and the Boolean values in a data frame. So you see that the number values are only ID, department, and the Boolean values is manager. And for each of that is going to give you the statistics when you do a describe. So you say count how many are there, what is the mean, standard deviation, and then it gives you the quartiles. So mean, standard deviation, and quartiles for each of the numeric columns that is there in the data frame, as well as the Boolean columns in there. Boolean internally is stored as a number, so this is why you see that when you do a describe, you see analysis for each of the columns. Now this is a good way to take a look at the data that is sitting there inside your data frame to understand what kind of distributions these columns actually have. Next we go to how do I iterate through a data frame. How do I go row by row, column by column in a data frame and do some operations on it. Pretty normal things that you would do. So for that there is this, you can loop through by the for loop. When you say auto data.iterate rows, it is going to return you back. When this iterate rows is going to give you the row number and the actual row itself. So when I do iterate rows, it's going to return the row number and the actual rows, and you can iterate through them. Similarly, when you do iter items, it is going to give you the column name and the actual column value. So this way you can iterate through the rows and the columns. And this specific example, first I'm iterating through the row, then I'm iterating through the column, and then making a check if that particular value is actually null. So PD is null. I'm going to print the value, row name, column name, and let us see how this operation goes. It is going to give you nothing because there is no column there that is null. So maybe I will just comment out this guy and just print everything else. And now you would see it prints out all the outputs that are expected. The false, the row number and the row and the column name. So the row number, column name, and whether it is null or not. So all of them are getting printed out. All the rows, column combinations are being printed out here. So this is how you can iterate through a row or a column, rows and columns in a data frame, and then you can make some operations on them as you would want to. Thank you.